TCP/IP addressing. We're going to cover what a TCP/IP address is, what the format of that IP address is, how to convert from binary to decimal, decimal to binary, the different classes that make up an IP address, and we'll conclude with a little discussion on IP subnetting. Okay, so what is a TCP/IP address? Well, it's a 32-bit number broken down into 4 what's called octets. Okay, an octet is 8 bits. So it's a binary number. This is how the computer sees it. 8 bits per octet. Now, the way the humans like to look at it is as a decimal number. So what we do is we convert from binary down to decimal, and then this is how we work with it. This is how we deal with an IP address. So within each 8-bit number, you can have any number from 0 to 255. And we'll cover how to convert from binary to decimal, decimal to binary. Now, what exactly is an IP address? Well, an IP address is something that will uniquely identify your host on the network. So it uniquely identifies a device, a router, a computer, anything that you want to access through the network needs a unique IP address. An IP address is similar to a street address. We've got a certain portion of that IP address that identifies what is the street that you live on, and then a certain portion of that IP address identifies which house on that street are you. And we'll see how we determine that breakout as we cover classes. So the first thing that we need to do is be comfortable with the conversion from binary to decimal and decimal back to binary again. Let's first cover the hard way. Well, we've got 8 bits per octet. Okay, so this is going to represent each one of our octets. Now, each one of these bits has a certain value assigned to it. We start with the bit on the far right, called the low order bit, and that one is assigned the value of 1. Now, as we assign values across, we're just going to double our number. So we have 1, 2, 4, 8, 16, 32, 64, 128. So each bit has a decimal equivalent number, value. So now if we were going to determine what is the decimal value of this binary number, then we would take all of the ones, take the value that is assigned, and add them all up. So 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 equals 255. So how would we assign a number other than 255? Well, simple. Just make one of these bits a 0. And now we add 1 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128, and we get 253. So wherever you have a 0, disregard that bit. Wherever you have a 1, add that decimal value. So that's how you convert from binary down to decimal. To convert from decimal back up to binary, what we do is take our number and determine what combination of binary bits will give us the value of 253. So that's kind of a pain in the neck trying to figure out which bit should we use to get the value that we're looking for. So let's cover the easy way. Well, the easy way is start Programs, Accessories, Calculator, and put it into scientific mode, and then change from binary to decimal. Put it on decimal, type in your number, click the button binary, bada boom. So I like to use the tools that are available to me, but it is important that we understand where the binary and decimal number conversion is coming from. Now, when working with IP addresses, an important thing to know is what is the breakout between your hosts and your network. So let's look at some default breaks between host and network. And these default breaks are known as classes. This is typically the way that you buy an IP address. You buy a Class A address, or buy a Class B address, or buy a Class C address. Now, there's actually 5 classes, A, B, C, D, and E. D is reserved for multicast, communication to multiple hosts at the same time. And E is an experimental class that's not in use right now. So the A, the B, and the C class is what we're going to talk about. So what do I mean by the breakout between the host and the network? Well, let's take a look at our binary IP address, and let's say that right here we made a breakout between network and host. Well, a network is everything on one particular side of a router. So we've got router here, router here. The network is that in between. So these hosts will all communicate with each other without going through a router. Whenever they need to communicate with somebody outside of their network, then they have to go through the router. So within one network, you have a nice little cozy environment. It's called a collision domain, where you don't really have to worry about anybody else's traffic except your own, because nobody's coming to you unless they have to get to one of your hosts, because there's a router there that keeps out broadcasts and keeps out traffic that's unnecessary, unwanted. So as far as networks go, you typically want to have a breakout of networks small enough where it's efficient, big enough where you can have enough hosts on that network. So let's say maybe you have 400 users that you want on one network. Well, you would want 400 hosts per that network. Or maybe you have 30 users. Or maybe you're totally thinking about efficiency of the network, and so maybe you just want 50 users per network segment no matter what. Either way, you need to have a breakout of these are the number of networks that I have to work with. So let's take a look here. If I say that this is my network, these are my hosts, then what I'm saying is I've got this many bits that I can arrange into a number of different network segments, this many bits that I can have hosts on each one of those segments. So I've got not very many network segments, a whole stink load of hosts. Okay, what if I were to make the breakout over here? Well, now I've got a lot of bits that I can dedicate to creating multiple network segments, and I've just got a few bits that I can dedicate to making a number of hosts on that network. So I've got 24 bits to make networks, 8 bits to make hosts per network. So we can see as we move through the spectrum that the Class A address will give you not very many networks, a whole bunch of hosts per network. Class B, pretty good mix between networks and hosts. Class C, a lot of networks, a few hosts per network. Now let's take a look at why these numbers are what they are. Well, when we're determining what class of address we are, the Class A address, the first bit in the first octet is set to 0. So if that first bit is set to 0, the rest of the combinations give us 127. But 127 is reserved for what's called the loopback address. You can always ping 127.0.0.1, and that will do a ping of your own network interface to verify your own functionality. So the entire 127 range is reserved for that loopback functionality. So the remaining numbers then, 126. So we have 126 possible networks for Class A. For Class B, what we have is the first bit is set to 1, the second bit is set to 0. And so now we have 6 bits that we can create networks with, and the total combination of bits for the 6 bits here, plus, remember that the breakout goes to here for networks, plus those 8, total number of networks that we can have for 14 bits, 16,000. Total number of hosts that we can have for 16 bits is going to be 65,000. One formula I like to use as a way to calculate how many hosts or how many networks can we have per the number of bits that we have is 2 to the bits minus 2. Whoops, excuse me. 2 to the bits minus 2. So if I take 2 to the 14 minus 2, I'm going to get around 16,000. These numbers are a little bit of an approximation. If I take 2 to the 16 minus 2, I'm going to get around 65,000. Now let's take a look at what makes a Class C address. Well, a Class C address, remember, is broken out here. So we've got network, hosts. The first 3 addresses for a Class C address, first 3 numbers, excuse me, are 1, 1, 0. So now we've got 1, 2, 3, 4, 5, plus 8, plus 8. So we've got 21 bits that can be dedicated for creating our number of networks. So 2 to the 21 minus 2 gives us approximately 2 million. So when the Internet is assigning addresses, if they're going to give out a Class A address, they can give out a total of 126 of these Class A addresses. Each one of those clients with their Class A address, they can either decide that they want one network with 16 million hosts on that one network segment, or they can subnet it however they want. We'll talk about subnetting in a little bit. If the Internet gives out a Class B address, they have 16,000 Class B addresses that they can give out. Each one of those Class B addresses, if I just got a Class B address, woo-hoo, got me a B, I can put 65,000 hosts on that Class B network. So I can have one network, 65,000 hosts, or I can break it out however I want. Subnet it down where I have multiple networks and fewer hosts per network. And then finally, Class C address. The Internet can give out 2 million Class C addresses. If I get a Class C address, I can have one network with 254 hosts, or I can create multiple networks, and the more networks I create, the fewer hosts I can have per network. So we've got Class A, Class B, Class C. Now the way that you can identify what type of network you have or what type of network you're working on is by looking at the first octet. If that first octet is a number from 1 to 126, that's a Class A network. If that first octet is 128 to 191, that's a Class B network. If that first octet has a value of 192 to 223, that's a Class C network. There are 2 networks that are known as internal networks. Now, what I mean by internal network is the Internet will not register these names in the root servers of the Internet. And so there's no way to actually get to an internal network through the public Internet. But you can use these internal networks within your company. Now, the nice thing about this is you can have maybe just one active live IP address that's on maybe your proxy server that also has mail on it. And so you still have surfing and internet email, but within your company, let's say you have 10,000 users, you can have all the internal network and just do whatever you want within it. You don't have to worry about, are there enough IP addresses for me? Can I get a Class B? None of those issues come into play because all you need is one address at the edge. You're using the internal throughout within. So those internal networks are 10.0.0.0 and 192.168.0.0. Now the way you identify a network when you're talking about a network is by putting a 0 in the last octet. Okay, we talked about class of address. We talked about the fact that an IP address is a binary number. Well, let's say that we have a Class B address, but we don't want 65,000 hosts on our one network segment. We want to separate it up into, let's say, 200 network segments. And we just want a smaller number of hosts per segment so that we can have nice, efficient traffic. Well, what you would do is you would establish a subnet mask. Okay, now by default, I just bought a Class B address. Okay, so I've got a breakout right here between network and hosts. So my default subnet mask, doing nothing, just take it just as it is 255.255.0.0. What a subnet mask does is helps you determine what your breakout between your network and your hosts. Where is that line drawn? Okay, so by default, Class B address I'm going to mask all of these bits. In other words, I'm going to say all 16 of these bits identify my network, and I'm not going to mask any of these bits. So all 16 of these bits identify my hosts. Well, what I can do, I've bought this. This is set in stone, so these particular first 2 octets, these are mine. I own them. So let's say it's 100.57. There's nothing I can do about that. I can't get more than just the 100.57 unless I go buy more. But I do have play with these 16 bits. I can set these however I want. So let's say that I want to say I don't want my breakout there. I want my breakout right here. Well, what I can do is I can make a subnet mask of 255.255.0. And now what I'm saying is I want to mask all of these bits. And so these are also going to be a part of my network. Now only these 8 are for hosts. Okay, these 16 bits, these are set in stone. These are what I bought. But these 16 bits, remember, I do whatever I want with them. And so I can vary these however I want to make additional networks. So I'll have 100.57.1.1, 100.57.2.1, 100.57.3.1. Every time I vary this number, I've got a new network. So what I've done is I've said, I know I have a Class B address, but what I'm going to do, I'm going to treat it as if it were 254 Class C addresses. So now I can put 254 hosts, but I can have 254 networks. Now, this is just a nice simple scenario of I'm going to mask all the bits, because when we mask all the bits, then as we vary the number by 1, we're on a different network. So .1 is a network, .2 is a network, .3 is a network. Nice and easy to think about. But you don't have to make a mask of 255. You can say I want my breakout to be right here. Okay, so now instead of saying 254 networks, 254 hosts, what I'm saying is I want 7 bits for the network, 9 bits for the host. So how do we figure out the number of networks and the number of hosts? 2 to the bits minus 2. 2 to the 7 minus 2 is the number of networks that we can have, the number of combinations for those 7 bits. 2 to the 9 minus 2, the number of hosts, the number of combinations for those 9 bits. So I can make the breakout however I want. Just remember, when you buy a Class B, you have that to play with. When you buy a Class C, you have that to play with. When you buy a Class A, you have that. Okay, so in this CBT Nugget, we covered what an IP address is, how to convert from binary to decimal, decimal to binary. We covered what an IP subnet mask is, and we also covered the 3 different classes of address: the Class A, Class B, Class C. I hope this has been informative for you, and I'd like to thank you for viewing this CBT Nugget.